Okay. Oh. Ah. Okay. Now, class, we go to balancing redox in basic solution. So, the same thing what you do with the balancing of redox in acidic solution. But the only takeaway here, or the only difference here, you need to add water in the compounds that has oxygen. Okay? But in the more oxygen, the reverse of acidic solution. The acidic solution, we have to put water in the other side if it is insufficient. But in basic solution, you have to add, okay, you have to add in the side where it has more oxygen. OH in the other side. So this is the only reverse. Again, very important. Okay, so no. In basic solution, okay, you have to add water to the more oxygen atoms in the compound. More oxygen atoms. And then add OH on the other side and balance the oxygen and hydrogen. In acidic solution, okay, put H2O or add H2O in the insufficient or deficient or the less oxygen atom. Okay. And add H plus. This is also OH negative, ha? When you mean of OH, automatically negative kasi yan. Okay, so we don't have to be precise. We don't have to say perfection all the time. Sometimes it's understood that OH is negative 1, right? Okay, so less oxygen atoms, then plus, okay, H plus always. So if I'm saying H plus always, you could have been saying also OH negative. Okay? Because in chemistry also, if we encountered OH, that would normally have a negative 1 charge. We don't have to mention that every time. That's why that's in my brain. Things like that. But here it's so special. H plus, H plus, H plus, right? Okay? So because the moment you don't put plus, problem in your balancing of charges. Okay? Things like that. Because in OH, you always remember that OH is negative. Even though you will not put negative, that's always negative 1. But here the H, it's confusing. Sometimes you don't have to put H all the time. Right? So that's why I emphasize always H plus, H plus, H plus like that. You get the point? Because it matters. Okay. Now we give an example. Okay. The first example will be dealing with chalice. Okay. Iron plus hypochlorite. I love hypochlorite, no? Is equals to iron 2 hydroxide or ferrous hydroxide and then plus chloride. Don't be afraid, guys, if there's no charge, because that would mean 0 under its free state and under their neutrality. Okay, things like that. Okay, things like it. Just like here, so ferrous hydroxide. What is the net charge? So obviously 0. Here. Okay? Things like that. You get the point? Okay. Because the moment the net charge will be not equal to 0, so it could either be the iron and hydroxide are charged. Right? Things like that. You get the point? Okay. Now balance. Now go to the first step. Designate and determine the oxidation reaction by assigning oxidation states. Okay, iron in a free state is 0. Okay, partner also with ferrous hydroxide here, or iron 2 hydroxide. Now we have the net here, right? So 2 times H positive 1 is equals to 2. 2 times oxygen is negative 2 is negative 4. Okay. Now, negative 4 plus plus positive 2 is negative. Negative plus 2. Negative 2. So therefore, positive 2 ang iron because positive 2 minus 2 is equal to 0. Now, it's so, I think it's correct, but for me, I'm not confident. I will use algebraic expression because somewhere along the way, I will be wrong. So, say, iron plus 2 OH parentheses is equals to 0. So this is telling also the same as distribution multiplication in math. So 2 times oxygen, 2 oxygen. Hydrogen times 2, 2 hydrogen is equals to 0. So iron will be 2 plus the charge of oxygen negative 2 plus 2 times the charge of hydrogen is positive 1 is equals to 0. Let's prove it if it's equal to 2 also in my first analysis during trial and error method. Okay, so iron is equals to 2 times negative 2, negative 4. 2 times 1, positive 2. Then Fe, negative 4 plus 2, negative 2 is equals to 0. Iron transposed, it will become 2. So perfect. 2 really is our oxidation state of iron. So I'm confident now. Okay. So let's erase this algebraic expression of getting the oxidation states. Okay. Now we go plus chloride negative. Okay, now let's pair that accordingly. Okay, you pair this iron because with iron here in the compound and the hypochlorite with chloride. So we have still another from the hypochlorite. Okay, oxygen negative 2 plus X oxidation number of chlorine. In order it will yield a negative net charge of 1. So it's gonna be, okay, let's say 1. 1 minus 2 is equal to negative 1. So perfect, that is only 1. We don't have to use algebraic expression anymore because the oxidation state is so small. Okay, things like it depends on the situation. Okay, where we need it the most. Okay, now, so iron, then positive 2, it becomes 0. Okay. Oh my gosh, it became 0. So what's this all about? Meaning to say, it loses electrons. The electrons of iron originally is being lost from the iron. That's why it becomes 0. Okay. Or increase in oxidation state, oxidation. Okay. Now, hypochlorite here. Take a look with the chloride only. Because you don't have to worry for the oxygen. The oxygen doesn't change, I think so. It's still negative 2, see? Negative 2, negative 2. Right? Okay. And that is not a partner. The iron 2 hydroxide, iron 2 hydroxide is not a partner of hypochlorite. That's why you don't have to take into account the oxygen. Okay. Things like that. So, since 1 to negative 1, it's decreased the oxidation number, so it's reduced reduction. Or increases the electrons. Or gain of electrons. See? It becomes positive 1 from negative 1 here. Okay? So that's reduction. Okay. Now half reaction tubas. Half reaction. The redox and the oxidation. So O. Iron. Do not copy the 0 during the half reaction. Is equal to Fe. Okay. Hydroxide. Times 2, like that. Okay, now, you said in oxidation you have to add electrons in the right. Right. Now, what electrons you will add here? Okay, here. What electrons you will add here? You know that from 0 to 2 is 2 electrons. Right. Okay. In here, the situation is different. Because if you try to let X as the number of your electrons will be added to iron 2 oxide, you still be confused because there's no oxygen in the reactant. So it's not really practical to do that. Okay, the first thing to do is to check the electrons loses. So that's 2. That's why plus 2 electrons to compensate the loss. That's why we add. Or to replenish. Or to replace the loss, then you have to add. Okay, so plus 2 electrons here. Okay, now, you have OH, right? Okay, you have OH here. Okay, so what will we do in the reactant? And it's very clear in chemistry. If you put things like that, say OH2, like that, for example, like this. So it will become twice OH. As I told you, subscript times the compound. So kaning subscript will be excited to the coefficient of hydroxide. So it will become plus 2OH on the other side. Why? Of course, to compensate the atoms of the hydroxides in the iron to hydroxide. So we need to put 2 moles of hydroxide here. Because if we add here, too much already. So it will not be balanced. Right? Things like that. Now, why we don't put water here? We don't put water anymore because the hydrogen are already balanced. Common sense. Because that's our technique in basic, right? See? See, why you put water? It's already balanced anymore by adding OH. So, there's no use anymore. Right? I'm not telling that you don't have to put water in the oxidation because it doesn't matter where to apply the adding of water and the OH somewhere along the way. It depends on the situation. But in here, no need because it balances both the atoms of oxygen and hydrogen. So, kalas, okay, don't put complexity in your mind. The situation is easy. You got the point, things like that. Now, balance atoms. Oh, iron, balance. Oxygen, 2 balance. Hydrogen, 2 balance. Okay, things like that. Now, how about the charges? So, it is balanced. Now, let's check. Let's balance the charges. Now, iron, solo flight, 0. 0 times 1, 0. Plus, negative 1 ang OH. Negative 1 times 2, negative 2 is equal to. Now, this one as I told you, all compounds that has no charge or that has no net charge are neutrality or neutral compound. The oxidation state and oxidation number is always equal to 0. The net is equals to 0. So, net 0. Okay, so 0 times 1 is 0. Okay, now here, Allegrino, 2 electrons. Instead of writing positive 2, negative 2. Why? Because an electron is a negative thing. So that's why we have negative 2 is equal to negative 2. And that's balanced. The gray area meaning the confusing part in this area is why you put negative 2 and you have 2 electrons, right? Because electrons is negative, you have to put negative 2. You get the point? So if you put positive 2, it will never be balanced, aside from knowing the concept really. If you are only interested on the sign. But if you are going deeper than the sign, that's why you understand that electrons are always negative. That's why you put negative 2. That's why negative 2 is equal to negative 2, so your charge balanced. Okay, perfect. Now we go to the reduction. Okay, reduction is in here, right? Okay, here. So, hypochlorite negative is equal to, okay, chloride negative. Okay. Now, as I said earlier, you have to add electrons on the left in the reactant, obviously. So, we need to put X automatically without question. So, what's X all the time? X is the unknown electrons to be added to hypochlorite to compensate the chemical reaction in a state of dynamic equilibrium with chloride. Here. Okay. Now, so there's insufficiency. Insufficiency meaning insufficient, deficient, or not equal or less number of oxygen from the right against the left. Okay, so we need to put here. That's the time we put water here. Water, H2O. Okay, things like that. So, the moment we put H2 also, the atoms of oxygen from the left and the right will be balanced. So, 1 atom here of oxygen, 1 atom of oxygen there. We introduce another H2. Then we have to add. Here, it's no longer H plus because this is basic. So, I told you, this is now OH. Okay, so OH plus OH. Now, take note. You have hydrogen 2 here. So it is 2OH. To balance hydrogen 2, hydrogen 2. Now there are 3 oxygen. Ganon siya. So how can you compensate that? 2 plus 1 is 3. And oxygen here is only 1. How can you do that, mga palagingging? Okay. So, you need to balance one by one here, the atoms. Okay. Things like that. Okay. So, for example, with this, in this regard, so we have the oxygen here. So, balance naman ang hydrogen. Hydrogen. Okay, and oxygen is 3. Oxygen is not balanced. So, here, we will X here. On the other side, algebraic balancing of atoms. So, we say, 2 plus 2 oxygen in the hydroxide and oxygen in the hypochlorite is equals to oxygen in the water molecule. So it's in here is the deficiency. We need to put X, the number of atoms of oxygen in the molecule water. So it's like X times 1 because there's no subscript of oxygen in the water molecule of oxygen. Okay, now it says 4, 2 plus 2 is equals to 4 is equals to X times 2 is X. So X is equals to 4. So put 4 here in the hydrogen. Okay, things like that. Okay, 4. Okay, because this is the efficient. Okay, so our oxygen is balanced now. 4 like that. Okay. Okay, let's solve for the hydrogen. Okay, this is 8 hydrogen. Okay, 8 hydrogen. And here is 2. So it's still deficient. So compute for the oxygen. Okay, 2 oxygen plus 1 because we're dealing with oxygen. Okay, manatali sa oxygen, hydrogen. Okay, you get the point. If we finish the hydrogen, obviously we go to the oxygen. Okay, hydrogen 2, nothing, then 8. So deficient here, so you need to put X in here like that. Okay, 2X. Okay, is equal to 8. So X is equals to 8 divided by 2X is equals to 4. So put 4 here. This is 8OH. Okay, things like that. You get the point? Ganon. You got na mga palangga kong hitad. Okay, now still not balanced. What you will do in here still not balanced in this reduction. So, guys, sorry guys because I did not solve this in actual. Okay, this is really on the spot. Okay, so here 8, 8. So it's not balanced again. So how can I review this? Okay, you need to review second time. That's why I told you maximum of second twice review. Okay. Now we need to review the steps of basic solution with regards to the takeaway H2O and the O. So I don't have to add water in the chloride side because chloride is deficient. I need to add water in the more of oxygen. Okay, H2O, okay, plus chloride, hypochlorite. Now, how much OH you will put here? So, because you know, if you keep on memorizing, then you cannot discover your mistake. You get the point? So that's why you need to review. Okay, and understand, oh, it's gonna, something went wrong. Okay, things like so oxygen 2, so 1, hydrogen 2, hydrogen 2, like that. Okay, chlorine is balanced na siya. Okay, atoms are balanced. So I just reversed the adding due to the steps recommended in the rules in redox balancing in. Don't forget this one. Okay, things like that. Because you know, maybe you will also like me that at first we will add water to the deficient oxygen atoms. Okay, it should be to the more oxygen atoms you will add water. And then other side is OH. It looks like also skeptical because normally in our normal chemical reactions also, we need to add something to the deficient one. But in here, it's a deviation. I need to explain. That's why I use that in the first place because I'm going to the general way of balancing in which you will put something deficient of atoms in the deficiency side. or insufficient set. But in the basic solution here, exclusive in redox balancing, you don't have to do that. You will add the water in the more atoms, not on the less, and add OH on the other side. So it's very, if you don't really go to the deep understanding, then we'll be in trouble, right? You get the point? Things like that's the problem. Really, if our study is only shallow or superficial, we do not go to the tips of the iceberg in our understanding, so problem. Okay, things like that. So, we put X here. So, balance the atoms are already balanced, as I told you a while ago, right? By visual inspection. Now, balance the charge. Water, 0, 0. Negative 1 times 1, negative 1. Plus X, as our unknown electrons to be added to hypochlorite to compensate the balance of chloride in the product. So, equal to negative 1 times 1, negative 1. Plus 2 times negative 1, so negative is negative 2. Okay. Now, negative X equals to negative 3 plus 1. X is equals to negative 2. So, this is 2 electrons. Okay. So, change the X to 2 electrons. Okay. Now, if you have 2 electrons, both are 2 electrons, very easy to cancel. Cancel directly. Because you need to add that. But take note, you cannot cancel if that is in the same side. It should be in opposite side. The other one is in the reactant and the other one is in the product. That's the rule in math. Okay? And you can cancel only the same sign. Whether it is variable or numerical figure. Okay? You can never cancel negative 3 and positive 3 if they are in the opposite side. Always the same. Both the numerical and the, if it is a variable with figure, both are the same. So 2x, 2x, 3xy, 3xy. But number also 3, 3, 2, 2. We can cancel. And also variable x, x, y, y in opposite side. Okay, not in the same side. You can cancel that one because it will be added. You got the point, things like that. Got on. Okay, so now you don't have to multiply the electrons with something because the electrons are stabilized already. Somewhere along the way, we produce 2 electrons in each half reaction, oxidation and reduction. Okay, don't force yourself to multiply to something. In fact, it's already equal. Right? Things like that. Okay, so Fe. Okay, remove the 0 because we are now the final net equation. You need to remove the 0. Okay, I think also the instructor will consider that one because it means also nothing, right? But I'm only saying to be precise. Okay, so Fe plus 2H negative, the whole reactants, you have to write here in circle. Okay, Fe 2H negative plus water, you don't have to put the 0 also. Okay, plus hypochlorite, okay, is equal to this one, so encircled. So iron 2 hydroxide or ferrous hydroxide, okay, plus chloride negative plus twice OH. This is our net redox equation in balancing in basic solution. Now check. Okay, check. Okay. They're still common with each of everything, the variable and the numbers. Then we can cancel that out. Wait. Fe plus 2H plus H2 plus hypochlorite. There's the OH still, so we need to cancel the OH. Twice OH, 2 moles of OH. That's the same thing, right? 2 moles of OH in each side. So cancel. So this will be our remaining, this one. Iron plus water plus hypochlorite is equal to iron 2 hydroxide plus chloride. Okay, things like that. Now, balance the atoms. So, iron, balance. Hydrogen, 2 balance. Oxygen, 2. Okay, 2 also oxygen here. Balance. Chlorine. Atoms, chlorine. Balance. How about the charge? I love the charge balancing, guys. Okay, 0. Okay, water, 0 also. Both element and compound has a 0. charge. Okay? Like that. So, negative, this hypochlorite, negative times 1 is negative 1. So, negative 1 is equal to, let's check in the other side. Iron 2 hydroxide, 0. 0 times 1, 0. Okay, negative 1 sa chlorine is negative 1. Okay, so, negative 1 equals to negative 1. Charges are completely balanced, so perfect. Our net redox reaction will be iron plus water plus hypochlorite plus iron 2 hydroxide plus chloride. So, in your equation here, you have only to add water. So, in your original equation, this is original redox, and this is the net redox or the final redox. As you can compare the two, if you have to have a comparative analysis or comparative study, you only add water to your reactant in order for your redox to become balanced in basic solution. See? See? Only water is added. Now, if you are very expert and clever, then you don't have to go further with this kind of whole process. You need to add water, only take water. So that is basic solution. But sometimes, it's not always all the time perfection in that manner. That's why we go to the process. Okay? Things like that. So, let's say that you are really expert and master and you need to add water directly. Okay? It's possible. Yes, it's possible to add water in the reactant because redox in basic solution, there's already OH in the product. Then you have to add water on the outside as in our steps. So, logically and practically, pasok sa banga. You get the point? Or really very significant to do that. It's paramount. See? OH and H2O. So, balance. Oh, oxygen 2, hydrogen balance. Perfect. So, things like that. So, if we don't go to the details, then just look at it and do it in that way. Now, we try to have an example. Let's use that direct if we can, not going to the whole process. Because the whole process, it will take a longer time. For example, another example, no? Okay, so we have sulfite, negative 2 plus nickel, okay, nickel 3 hydroxide, right? Remember nickel 3, okay? Okay, negative 1 is equal to nickel plus SO4 to negative. Okay, wait. What is the atomic weight of nickel? It is 58.69 grams per atom because the cobalt is 58.93 grams per atom. They are more closer kasi in the numerization. The cobalt and the nickel have a closer atomic mass of 58 something. And the tellurium and the chromium also are closer with each other, rounded out to 52. Chromium and tellurium. Okay, and the manganese will be 54.94. So, you should memorize at least some of the atomic weights and atomic masses. Okay? Things like that. Okay. Now, if we try to add water directly to us, can we make it? Now, our OH is in the reactant, so we can add water here directly without having that whole process. Let's say, if we will have the same thing also if you go to the process. Okay, H2O plus nickel plus sulfates. How many oxygen we have now? So it's 3 here, 6. So here is only 4. Then we need to add 2 here. So that it will become 6. I'm doing the trial and error method just to make it quick. So 4 plus 2, 6. 6. Now how about your hydrogen? Hydrogen is 4. No, so you need to make it 3. Because this is prime or odd number. It's very difficult to equal that with even number all throughout. Mamatay lang ta. It should be always the odd, also you will partner that out. Okay, things like that. So 3 times 2 hydrogen, oxygen, so this is gonna be like 2 here also. Okay, so 6 hydrogen. And then oxygen will be 6. Okay, so sobrang oxygen because we have here 4. So let's say we adjusted that to something 3. Okay, 3 times 4, 7 man siya. No? So napamatay 3 dire alis ako, no? So 3 plus, kung ano na tubukan na siya ng 2, kaya narapan naman tayo kilid. Oh. So 6 hydrogen na siya. 6 hydrogen, 2 siya. Hydrogen, so 6 man, Oxygen is 7, napamatay dire 3. Okay. So 6 plus 3, sobra siya. So that's gonna be 3 plus 4, kuwang siya 2. So, let's make it, so no choice. Let's do algebraic expression of balancing because the moment I will feel sorry guys, the moment I will feel difficult in the error method, I will use the algebraic expression of balancing the chemical equation. It's better. Okay? I'm not really expert to the trial and error method in the name itself, kuyoking ma-error. Because the point things like that. So we go to algebraic expression of balancing the chemical equation. Okay. Sulfur, balance. What is the atomic weight of sulfur? 32.2 grams per atom. Okay. Nickel, balance. Okay. Oxygen, mga palangging-ging, dili. So, we start with oxygen. So, oxygen here, 3 times 1, 3. And here, 3, 7. Here in the other side, okay, 4 plus 1 is 5. Deficient in the right. So, we need to put X somewhere along the way. So, we need to put X in the water. X atoms of oxygen to balance the 7 atoms in the reactant. We choose water because water have small oxygen atoms compared to the sulfate. We cannot put X here beside the sulfate. You get the point? So listen, X times 1 plus 4 times 1 because oxygen here is 4. Okay, 6 is equals to X plus 4. Then, okay, is equals to 6. So X is equals to 6 minus 4. X is equals to 2. So put 2 beside hydrogen. Okay, things like that. Now balance again. Okay, hydrogen. Okay, balance na sa hydrogen na po. Balance oxygen, balance ito. 2 plus 4, 6 na siya. 6. Okay, hydrogen. Charos. Hydrogen, mga palaging. Okay, hydrogen. Okay, this one. 3. 4. So balance here. X here. Beside nickel. Because the hydrogen is less. So it's gonna be 3x, so 3 times x. 3x is equals to 4. X is equals to 4 over 3, 4/3. Fraction. Okay, then put the fraction beside nickel, 4 over 3. Okay, that's why I told you, it's not good to have trial and error method. Okay, so 4 over 3 fraction. And we need to cancel the denominator because we are not allowed to put fraction in our atoms. So multiply the whole thing with 3. So it's become 3 times sulfide, so 3 is 3 negative 2. 4/3 times 3, cancel the 3, that is 4 nickel. Okay, like that. Okay, nakakaloka. Is equals to 3 times 2, 6 H2O. Plus 3 nickel na pa, 3 nickel plus 3 sulfate. Balance naman ni siya. Okay. Sulfur 3. Sulfur 3. Okay. Nickel 4. It's not balanced the nickel 4. Because nickel 4 here, see? And here, nickel is only 3. So how can the nickel will be balanced? It's not balanced really. So how can we do that? Okay. Take note the hydrogen. 12, balance the hydrogen. Ang oxygen, 4 plus 6, diba? So it's gonna 10 here. Okay, here. 12 plus 6 is 18. So the oxygen is not balanced. So you need to rework again your oxygen. Okay, this is it. This is algebraic. We cannot do about it. Okay, so oxygen. So asa man ang yung less deriary. Okay, 12 deriary, oxygen. So water again. Oxygen. Sige, go. 3 times 3, 9. 3 times 4, 12. Okay? Oxygen, X diri ari, so 6X. Okay, oxygen 12. Okay, because we let X here beside the water. Okay, things like that. So, algebraic expression na naman, no? So, 21 is equals to 6X plus 12. Linear lang, no? Is equals to 21. So, 6X is equals to 21 minus 12. Divided by 6, divided by 6. So, X is equals to 21 minus 12, mga palagingging. 21 minus 12. 9. 9 over 6. Oh, divisible by 3. So, this is gonna be 3. 9 divided by 3, 3. 6 divided by 3, 2. So, 3 halves. Then put the 3 halves also in the water here. Oh, 3 halves times 6. Oh, again, we work. Because it involves fraction. Right? Don't surrender, ha? Okay. So, 3 halves times 6. 18 divided by 2 is to become 9. 9 moles of water. Okay. Things like that. We don't have to multiply for something because it's already exact when you do the operation beside the moles of water. So balance again.